Welcome back to Aurora Tech Channel. After reviewing the Creality K1 a few weeks ago, today I will be reviewing its pumped-up version, the K1 Max. This fully enclosed mid-size machine offers a print volume of a 300mm cube and shares the same impressive appearance as the K1. Both models use a Core XY kinematic system, with a motion system based on linear rods, and their Z-axis is supported by 3 lead screws. The K1 series runs on Clipper firmware, boasting a maximum print speed of 600 mm per second with a 20,000 mm per second squared acceleration. Unlike other Clipper bed slingers, which require attaching an accelerometer to the print head and the bed for input shaper calibration, this machine has an accelerometer inside the print head. The hot end uses a ceramic heater, providing more efficient heating compared to a regular heat cartridge. The maximum flow rate is 32 mm cubed per second, and the nozzle can reach a maximum temperature of 300 degrees Celsius. Just like many other latest generation machines, it features auto Z offset with auto bed leveling. There are no leveling knobs, and you don't need to use the paper test to set the nozzle height, as the nozzle probes the bed to create a mesh by reading data from the 3 strain gauges underneath the bed, which also sends the distance between the nozzle and the bed. The heated bed is an AC heated bed, and the rated power of the bed is 800 watts. This AC heated bed is likely to heat up much faster than most DC heated beds. For part cooling, besides the cooling fan inside the print head, there is also an 18-watt auxiliary fan positioned at the side. For network printing, you can use the Creality print slicer to print directly over your local Wi-Fi, or upload the Gcode to the cloud if you want. Alternatively, Gcode files can also be uploaded using the simplified Fluid Web interface or using the USB drive to print completely offline. The motherboard is using an Ingenic X2000 chip, which includes a dual 1.2 GHz processor and an additional 240 MHz processor. The K1 Max comes with a 4.3-inch touchscreen featuring a new user interface. Besides sharing all these features with the K1 Max also has a micro LiDar, so you can do pressure advanced calibration, and a built-in camera so you can record time-lapse videos. I would like to thank Creality for sending me this machine to review. But before we get started, I would also like to thank Sunlu for sponsoring today's video. Sunlu has been involved in the 3D printing industry since 2013, so if you've been part of the 3D printing community for a while, you might be familiar with their filament. They have their own factory and a dedicated R&D team that stays up to date with the latest market trends. Personally, I really like their recycled filament series, which are priced at an affordable price of $9.99 per roll, as I appreciate the idea of reusing plastic to help the environment. Besides that, Sunlu also offers a wide range of options, including regular PLA, strength-enhanced PLA+, carbon fiber-filled PLA, and other more unique choices like twinkling, silk, rainbow, and wood-filled PLA. They offer PETG, ABS, ASA, and flexible TPU filaments as well. They also provide accessories like filament dryers and various types of 3D printing resins. For more information, please visit sunlu.com. The K1 Max comes in one piece, just like the K1. So, you only need to remove the protective materials, mount the screen and the filament holder, put these 4 rubber feet at the bottom to work as vibration absorbers, and install the door handle. Besides that, we also have some tools, a power cord, and a set of high-temperature hot ends with a hardened steel nozzle. When you turn on the machine for the first time, it will do some quick tests, including heating up the nozzle and print bed, as well as testing the fans. After that, it will do input shaper calibration, where you will hear the machine shaking and making noise. This is followed by auto bed leveling. The whole process will take around 15 minutes. Let's load some filament and start our first print. I will start by printing a 3D Benchy with no flow calibration. This is the option to enable the micro LiDAR for linear advanced calibration, which I will test out later. But first, let's start with the benchy and see if everything is working normally. The Auto Z offset is set a bit too low, so the first layer is squeezed down more than I would prefer. After the bottom is printed, the machine starts to speed up. Let's test the sound level. With the door and top cover open, the sound level measures around 70 decibels, with the sound meter just a few inches away. When fully enclosed, the sound level stays in the mid to high 50s. The print quality is in line with the K1. The surface isn't perfect, but the input shaper should be working, as if not, the surface will look much worse when printing at high speeds. The cooling and layers look alright. As this white Creality Hyper PLA hides the layers and artifacts pretty well, I will change to the blue color Hyper PLA to start another print. This time, I will turn flow calibration on. It will enable the micro LiDAR and scan the left side of the bed, then print a zigzag pattern and scan it again. Compared to the one printed with white PLA, the blue filament more clearly shows the imperfections in the surface, like how there is more ringing here and how the layer lines look more obvious. I will print the same model again with Sunlu PLA and see the result. The result is in line with the blue Hyper PLA, and some ringing shows up at the same area. Here is a comparison of printing a 16-minute benchy with 3 different filaments at this machine's top speed. I also tried to reslice the model using Creality Print at a normal speed of 200 to 300 millimeters per second at a 0.2 layer height. It took 42 minutes to finish. This 42-minute one looks much better, and it's not far from a standard 1 hour and 15-minute benchy. The layers and surface print quality are much better than the 16-minute benchy. Next, I will try printing a calibration cube. The first one will be printed without using the micro LiDAR, and it will be pretty much like a normal calibration cube. I will then print another one with calibration enabled. As you can see, it will print some patterns on the left similar to the benchy I printed previously. Let's compare these two cubes. As far as I can tell, they're identical, so I don't see any difference in whether or not you use the micro LiDAR. It looks like the hardware is here, but the firmware isn't quite ready yet. Let's just move on and conduct some more tests. I will try the 600 millimeters per second test print from Creality, starting with Sunlu Blue PLA. It took only 10 minutes to finish, and it seems that the Sunlu PLA can keep up with the top speed of 600 millimeters per second. This model was printed at a 0.1 millimeter layer height, and the layers and surface quality are really good. Even when zooming in close, I can't see any issues. Next, I will reprint this using Creality Hyper Blue PLA. When the printer is operating at its top speed of 600 millimeters per second, the sound level is a few decibels higher than printing the benchy, staying around the low to mid 70s. I guess this is the noisiest sound the machine can make. When it's fully enclosed, the sound level stays in the low to mid 60s, which is also a few decibels higher than when printing the benchy. The print quality of both filaments is really similar, so I can't tell if one is better than the other. As Sunlu also has a recycled filament series, I will now test their black recycled PLA and see how it works. Surprisingly, it still looks pretty good. When comparing all three filaments, I still can't determine if one is better than the other. All of the filaments can keep up with the top speed of this machine with pretty good results. Next, I will do more test prints with PLA and print a number slider. When using a regular printer like the Ender 3S1, it needs 9 hours and 40 minutes to print this model. However, with the K1 Max standard PLA profile in Creality Print, it only needs 2 hours and 22 minutes, which is 4 times faster. The print finished in 2 hours and 25 minutes, which is in line with the estimated print time. It looks perfect from the top, but the first layer is squeezed down too much, making the tiles connected with one another. I had to use some force to break the first layer to make it work, but the other layers have good clearance. So, this slider is still kinda functional with some extra work. After the release of the latest firmware version 1.3.1.18, I printed the same model again. It seems that the Auto-Z offset has improved a lot, providing enough clearance for the first layer. The print turned out perfect. After that, I will print a larger model. The height of this Captain America model by Eastman is 250 millimeters. When using an Ender 3S1, it would need 32 hours to print, but on the K1 Max, it only needs 7 hours, which is 4.5 times faster. The print took exactly 7 hours to finish, and I think the result is pretty nice. The print quality is presentable, and there are no major issues on the surface. Then, I will print my mini honeycomb box to test the retraction of the extruder. This model will take around 2 hours and 7 minutes to print, while an Ender 3S1 would take 5 hours and 42 minutes. It's only 2.7 times faster, as printing something at this size with tiny patterns doesn't leave much room for the machine to accelerate to a much higher speed. However, a speed of almost 3 times faster is still not bad. The result is alright. All patterns were printed without any broken honeycomb, unlike the one printed on the Prusa MK4. However, the stringing on the MK4 looked better. So, I would say this box from the K1 Max is not the worst or the best, it's just an average print. Then, I will print a drawer tower. When using a standard 3D printer, I have to print the drawers and tower separately, which takes 15 hours plus 12.5 hours, totaling 27.5 hours. However, with the K1 Max, it will take less than 7 hours, which is 4 times faster. The result is not too bad. The surface has some ringing, but for functional parts like these drawers, this quality from printing at 4 times faster is still acceptable. Up next, I will print a lion model using Sunlu Twinkling Blue PLA. I will try to add some thin tree support to the model, and it will need 2 hours and 36 minutes to print. The support for the tail is wiggling, but let's see if it can finish successfully. The model was printed nicely except for the tail. If more support was added, this model would have been perfect. However, looking at it from this angle, it's still not bad. Then, I will print a heart box at a 200% scale using Sunlu Twinkling Blue PLA. When using an Ender 3S1, this model would take over 10 hours, but with the K1 Max, it only takes 2 hours and 14 minutes. The print finished in 2 hours and 11 minutes, which is very close to the estimated time. The box looks super nice, and the clearance is also good, making it totally functional. For the last PLA print, I will print a Robo Alpaca, which I've recently printed on many printers, so I will also print one on this K1 Max for comparison. These are 4 different angles of the model, and it looks pretty good. Let's compare it to the models from other latest generation machines. The K1 Max and the K1 models are basically identical. In comparison to the Bamboo Lab P1P, the surface of the P1P is slightly cleaner, and the ghosting of the text also looks better. The Prusa MK4 is the best in terms of print quality, but it took almost 8 hours to finish the print, which isn't quite comparable to a 4 to 5 hour print. Up next, I will try printing with some TPU. I will print a simple box with just 2 walls and a bottom with 0% infill to make it a card wallet. You may be wondering why such a simple model will take over an hour to print on this fast machine. This is due to the settings of the default TPU profile, where the volumetric speed was set to just 3.5 mm3 per second. If we divide this number by the layer height and nozzle diameter, it means we are just printing at 43.75 mm per second, which is basically the same as a regular machine. This model didn't print quickly, but the extrusion of the TPU is perfect, and I have no complaints. Now, let's try another material that can't be printed too quickly. I will use Sunlu recycled PETG to print this trash can. Since this machine only comes with a 0.4mm nozzle, printing a model this big with vase mode means it won't be usable at all, as it would break too easily. So, instead of vase mode, I will print 4 walls and 4 bottoms with 0 top and 0 infill to make a more rigid trash can. Let's do a preview, and you can see we will print 4 walls instead of just 1 with vase mode. The print will take over 11 hours, which is not fast. One reason is that we are printing 4 walls, and another reason is that the volumetric speed of PETG is set to 9 mm3 per second by default, limiting the maximum print speed to 112.5 mm per second. PETG can't be printed as quickly as PLA. Even if your extruder is strong enough to melt it quickly, it won't stick like PLA does at high speeds. The print finished okay. With PETG, it tends to string a little more than PLA, but the stiffness of this trash can is pretty good. I think it can last quite a long time compared to my other PLA prints. Before switching to the hot end with the hardened steel nozzle, I will print an ABS crate. With an Ender 3S1, it would take 11 hours and 46 minutes. With this K1 Max, it still takes 3 hours and 39 minutes, which is fast, but I honestly expected it to be faster. The reason is the default ABS profile, as it's also limited to 9mm cubed per second, which will limit the maximum print speed to the same 112.5mm per second as PETG. This is a bit strange to me, as ABS can be printed at the same speed as PLA or even faster, but I will just stick to the default ABS profile in Creality Print. During the summer, the temperature in my garage can reach 34 to 35 degrees Celsius. When I was printing this ABS crate, the room temperature was 32 degrees Celsius. When the bed is set to 100 degrees Celsius, the chamber temperature can reach up to 59 degrees Celsius, so it's almost like a heated chamber. As glue is applied to the bed and the machine is fully enclosed, the print didn't warp and there's no layer separation. It seems this recycled ABS works pretty well. Then, I will switch to the hot end with the hardened steel nozzle. I will print a set of pliers from 3dprintedhardware.com using cheaty nylon carbon fiber. When printing with filament that doesn't require the auxiliary fan, the printer is much quieter, especially when it's fully enclosed. The sound level is just around low to mid-40s. It may go up to the mid-50s when it travels at a fast speed, but the sound level is still pretty quiet for a high-speed machine. The result is really good. When comparing it to the one printed by the cheaty X Max 3 with a heated chamber, this K1 Max prints just as well. Finally, I will print a tent stake with polycarbonate. The estimated print time is 52 minutes. I added some tree support for the overhanging part as I turned off cooling when printing polycarbonate, so it will be challenging to print the overhang. At night, my garage temperature drops to around 25 degrees Celsius, which may be more like a normal room temperature. The chamber temperature can still stay at around 49 degrees Celsius, which is still good enough for most materials. The print took 53 minutes to finish, and it stuck perfectly to the bed with glue. The glue just acts as a release agent, as PC may stick too well to this type of print surface. The overhanging part printed with support is not perfect, but this model is still functional and can work as a tent stake. Okay, let's talk about the pros and cons of this machine, starting with the pros. 1. The new K1 series machines are fast. Just like the K1 Max can print at the same speed as the Bamboo Lab machines and still retain presentable print quality. The stepper motors on the X and Y axis are NEMA 17 58mm high torque motors to support the 600mm per second speed and 20k acceleration. When printing with the default PLA profile, it will print at around 200 to 300mm per second with pretty good results. 2. The top of the machine is one-piece aluminum. The entire frame is more sturdy than the frames on other printers made of aluminum extrusions and tightened using screws. 3. The auto leveling and auto Z offset work well. So you don't need to manually adjust the distance between the nozzle and bed, and the machine just calibrates everything itself. With the stock firmware, I found that the K1 Max tended to set the nozzle distance a bit closer than I would like, but after the latest firmware update, it's working much better and can print a single layer sheet of PLA without too many issues. Four, it prints well with almost any material. I tested PLA, PETG, ABS, TPU, nylon carbon fiber, and polycarbonate. It handled most of these materials well, even at higher printing speeds. 5. The AC heated bed heats up quickly. It took less than 2 minutes to heat up from 25 to 60 degrees Celsius, and only 4 minutes and 20 seconds to reach 100 degrees Celsius. 6. For those who don't like using Creality Cloud, you can get rid of it completely and just send the print job over your local network directly from the slicer. The latest version of Creality Print has improved a lot, and it's now an overall usable slicer. If you still prefer using your own slicer, you can upload the file using the web interface, but you can't use the micro LiDAR features. 7. This fully enclosed machine prints tough-to-print materials like ABS and polycarbonate extremely well. A well-made enclosure alone will cost you $300, but this machine comes with a glass door, pixel glass side panels, and a glass top, so these parts are well made. When the machine is fully enclosed, the interior can reach up to 50 degrees Celsius in a 25 degrees Celsius temperature room, which is good enough for ABS or other materials that require a warm ambient temperature to print. The K1 Max has also added an air filter that wasn't included in the K1. 8. Both this machine and the Qidi Max I tested last week come with 8GB eMMC onboard storage, but the Qidi Max only has a few hundred megabytes of free space after installing the OS, Clipper, and other system files, making the machine run out of space after printing 20 to 30 larger Gcode files. The K1 Max has over 6GB of free space, meaning the K1 firmware is more compact and the file and resource management is also doing much better. You can print hundreds of files without worrying about space and having to delete some previous files. Now for the cons. 1. Creality Print has had quite a lot of improvements compared to its earlier versions. While it's not far from the original latest Cura, it still falls a bit short of the capabilities offered by the Prusa slicer. The slicing speed and other features like support painting don't work as effectively as they do in the Prusa slicer. However, I would still prefer to see Creality keep the Moonraker plugin and let users send print jobs directly from Cura or the Prusa slicer. This would offer more convenience and flexibility in the printing process. 2. The extruder gear is made of plastic, and so far it has worked fine without any issues for most models. However, for the tiny honeycomb box that requires an excessive amount of retraction, there is a bit more stringing than I would prefer. Additionally, I have come across some users' complaints about under-extrusion with their K1 or K1 Max. You may need to adjust the angle of the Bowden tube to avoid a sharp, steep turn that results in friction. Alternatively, you can opt to either create a DIY solution or print a filament holder to attach to the side. This can also ensure that the filament can feed smoothly. Like almost any fully enclosed machine, the K1 Max follows the Ultimaker approach of placing the filament at the back. This positioning makes it harder to access unless you place the printer on a table that lets you reach the back easily. 3. The K1 series doesn't support multiple filament upgrades. If you need to print multiple colors or use water-soluble filament or breakaway filament to print support, you need to buy a Bamboo Lab machine with an AMS multiple filament system. 4. Regarding the micro LiDAR, the hardware has been installed, but the firmware is not quite ready yet. When I enabled the Linear Advanced feature, which they called Motion Advanced, the LiDAR did scan and it appeared to be doing something. However, in reality, it didn't seem to have any effect on the calibration cube's overshot corners, which look identical whether or not the Linear Advanced feature was enabled, even with the latest firmware update. Moreover, the K1 Max product page also mentioned that with the micro LiDAR, the machine can enable dual bed leveling. In addition to using the 3 strain gauges at the bottom of the bed, the micro LiDAR is supposed to scan the print area and provide more precise bed leveling. However, this feature is also not yet available. It is crucial for Creality to release new firmware as soon as possible to enable these features and fully reach the micro LiDAR's potential. In conclusion, the Creality K1 Max's performance is in line with the K1. It's a pumped-up version of the K1 with a larger 300mm cube print volume and includes some extra features like the AC heated bed, an AI camera, a micro LiDar, an air filter, and an additional high-temperature hot end with the hardened steel nozzle. The price of the K1 Max is $300 higher than the K1 at $899. Despite the current firmware not fully supporting the micro LiDar, the K1 Max is still a highly competitive model in the market due to its hardware and features. I was close to giving it the title of the most advanced mid-size high-speed printer on my recommendation list on my website, which currently only recommends 7 machines out of the 100 machines that we have reviewed. But as the micro LiDar is not fully functional, I think I have to postpone this decision and wait for the possibility of a future firmware update from Creality that will make the micro LiDar fully functional. If such an update is released, you will find the K1 Max included in my list. If not, we will have to see which machine ultimately claims that title. If you're interested in the Creality K1 Max, I included the link in the description. That's all I wanted to share about this machine. If you found this video helpful, please consider giving it a like and subscribing to our channel. Thank you for watching, and I will see you next time.